This video is on Venn diagrams. A Venn diagram consists of a universal set U, or remember sometimes it can be that symbol, represented by a rectangle, and subsets within U are generally represented by circles. Depending on the problem, each element can be drawn in the diagram or the number of elements can be written, so you may see it either way. First example, we've got the set S, which is 2, 4, 6, 7, within the universal set of x such that x is less than or equal to 10 and x is an element of z plus. Draw a Venn diagram. Now the thing to remember with a Venn diagram is that it has to be inside a rectangle. If you don't have the rectangle, your Venn diagram is not drawn correctly. Now we've only got one set inside, so your rectangle represents the universal set. So your U or your E. And we've only got one set inside it, which is S, which means we just need one circle. Now we're going to call that circle S, and in S we've got 2, 4, 6 and 7. So I'm going to write those numbers inside the circle. Now the universal set is all numbers less than or equal to 10 and an element of z plus, so it has to be a positive integer. So all we have to do now is write the rest of the numbers that are not part of S in the rectangle, which will be 1, 3, 5, 8, 9 and 10. Now those numbers are still a part of the universal set, so they have to go in the rectangle, they just can't be in the circle, because in the circle we can only have S. Now part B, list the elements of S dash. Now remember, S dash is S complement, or the complement of S. So the complement of S equals everything not in S, which will be 1, 3, 5, 8, 9 and 10. The next questions are wanting us to find how many numbers. When you have an n in brackets, that's how many numbers are in S, not what are the numbers. So NS means how many numbers are in S. So if you look in S, in the circle, we've got 4 numbers in there. So N of S equals 4. S complement, the number of elements in the complement of S. If we look over here, we've got 1, 3, 5, 8, 9, 10, which is 6 numbers. NU, how many numbers are in U? So how many numbers do we have in total? Which if you count them all up, you'll see there's 10 numbers. Okay, next example. Illustrate the following numbers in a Venn diagram. Square root of 3, 8.5, negative 2, 7.1, 16, 0.115. So we've got to think, how could we represent these? What we're actually going to do is, a clue here is that our universal set has been given the name R, which suggests real numbers. So when we are drawing our Venn diagram, we're going to use a number system. So we'll have our lowest one is n, natural numbers. Then we have integers, and then we have rational numbers. So that'd be n, z, and q. Now we just put numbers in the right spot. So first of all, I like to start at the middle of a Venn diagram and work out, so what natural numbers do I have? Anything 0 and up that's positive, so we've got 16. Z, any integers. So our integers are negative 2 and 16. But 16 is already in the diagram, so we can't write it twice, so negative, we'll just have the negative 2. Because if you look, that 16 is still in the integer circle. Q is rational numbers, so anything that can be written as a fraction, which will be 8.5, 7.1 we can write as a fraction, and 0.115. And I'll cross off the ones that we've done. Now square root of 3 is still a real number, because it's an irrational number. It just doesn't fall into any of the other categories, so we can write that on the outside. Example 3, our universal set is x such that x is between 0 and 12, including them, and it's an integer. And then we've got A is 2, 3, 5, 7, 11, and B is 1, 3, 6, 7, 8. Draw a Venn diagram. So now we've got 2 sets inside of U, which means I need to draw 2 circles. More often than not, when you draw your 2 circles, they will overlap and cross. And if you look here with A and B, there are a couple of numbers that do cross over between the 2 sets. So when we draw this Venn diagram, we're going to draw 2 circles that also overlap. We'll label them. So this one's going to be A, this one will be B. And then we input the numbers. So once again, like I said, I like to start in the middle. So this middle section here, I'm just going to quickly shade and then delete it, this bit here, are for numbers that are part of A and are a part of B, which are 3 and 7. I'll cross them out from the original sets. Now in A, we've got 2, 5, 11 left, so that can go in just the A section. And in B, we've got 1, 6 and 8 left. Now a universal set, remember, goes from 0 to 12 including. So we have to put the rest of those numbers into our Venn diagram. So it'll be 0, 4, 9, 10 and 12 that we've got left over. When it comes to Venn diagrams or probability as well, we have these two things called union and intersection. If we have two sets A and B, and you'll see this symbol from the first video that I did, these two symbols here. The one that kind of looks like an N is the intersection of A and B. And we say, when we're looking at the intersection, we're looking at elements in both A and in B. So in that Venn diagram there, the shaded part in the middle. Now the U kind of symbol is the union. And it's elements in A or B, or both. So in our Venn diagram, it's all the circles, because it's A or B or both. We can also have two sets that are disjoint or mutually exclusive. They don't have any elements in common, and that means the intersection of A and B doesn't exist. So it's the empty set or the null set. Example here, we've got our universal set is positive integers that are less than or equal to 12. A is prime numbers less than or equal to 12, and B are factors of 12. List the elements of A and B. So A equals, A are primes less than or equal to 12, which would be 2, 3, 5, 7, 11. Remember, 1 isn't a prime number. B are factors of 12, which would be 1, 2, 3, 4, 6, and 12. We want to put these on a Venn diagram. So we've got two sets A and B, which have got two circles. Now we want to look, do we have numbers that overlap between them? Yes, we do. So we will draw two circles that overlap. Call them A and B, and then we can start putting our numbers in. So numbers that are common, we have 2 and 3. The rest of the numbers in A are 5, 7 and 11. In B, we have 1, 4, 6 and 12. Now we've just got to think, are there any numbers we haven't used? Our universal set is positive integers less than or equal to 12. There are some numbers we've still got 8, 9 and 10 to represent. Now some questions about this Venn diagram. List the elements in the complement of A. So we're on all the elements not in A. So if you look at the diagram, you look at everything that's not in that circle of A, which will be 1, 4, 6, 8, 9, 10 and 12. Part 2, I want to list the elements in A and B, so that's intersection, so the A intersection B, which when we think about saying it, we say A and B, which is the middle section, so that's 2 and 3. And the last one, the elements in A or B, or A union B, which is anything in the circles. So we 1, 2, 3, 4, 5, 6, 7, 11 and 12. D. Find the number in A and B. So how many are in A and B, which is 2. How many in A or B? So all the numbers, how many numbers are in the circle, so just add them up. Be 9. And the last one, the number not in B. So the number of the complement of B, so how many are not in B. So you just look at everything that's not in the circle of B, and you'll see there's 6 numbers. Now that's one way you can represent Venn diagrams. The other way is numbers in regions. So rather than writing each element into the diagram, you just write how many numbers are in there. So a Venn diagram has 4 regions, and you can see the notation there. So you've got the middle, which is the A and B, the intersection here. This part here with the A is A and not B. And the other side is not A and B. And the outside is not A and not B. So a lot of Venn diagram problems, we are only interested in the number of elements in a region, not what's actually in them. So first example. How many elements are there in A? So the first one, how many are in A? You just look at the number in the circle of A. Now the circle of A is all this. So the number in A would be 17 because it'd be 12 plus 5. Now we want how many are not in B. So if we look at not in B, B is this circle here. So you want everything not in that circle, which will be 12 plus 6, which is 18. Then the last one, the number in A or B. Now remember, A or B is both circles because it's one or the other or both. Add those numbers together and you get 25. D, we want A, but not in B. So we can write that as A, but not B. So it's A and not B, which is just this part of A. Because remember that 5 is included in B. So it's just a 12 because we don't want B. B, but not A, would be not A and B, which on our Venn diagram is the B part, not including the middle, which would be 8. And the last one, neither A nor B, which will be not A and not B, which is not the circle, so everything outside, which is 6. Next example, we're told that the number in U is 25, in P we've got 10, in Q we've got 12, and in P and Q there's 3. We want to work out how many are in P or Q. So what we might like to do quickly here is draw a really quick Venn diagram. We've got P and Q as our circles. Now we know there's 3 in P and Q, so there's 3 in the middle. Now the number in P is 10, so that means that whole circle of P has to be 10, which means there's actually only 7 in this section here. Now the number in Q is 12. Now that also includes the 3, because that 3 is in the circle of 12, which means that is 9. So the number in P or Q is 7 plus 3 plus 9, which is 19. Now we've worked that out, we know our total is 25, so in the outside part of the rectangle we must have 6. And then for B, the number of P but not Q. So we want the number in P and not Q, which is this part here. So remember, we don't include the middle part because that is in Q, so it's just 7. Then to put this into some different contexts, and often it's problem solving questions. So we have this Venn diagram here that illustrates the number of people in a sporting club who play tennis and hockey. Let's first of all, how many people in the club? Nice and easy, we're wanting how many are in the universal set, so all of them, so you just add up all the numbers. So 15 plus 27 plus 26 plus 7, which is 75. How many people play hockey? So the number in H, which remember is the whole circle of H, so it'll be 27 plus 26, which is 53. Next, C, who play both sports? So both sports is the middle, the intersection, which is T and H. D, who play neither? So neither is the outside. So not T and not H. So that's 7. It just tells us that right in the diagram. The last one, who play at least one sport? So at least one sport is actually everybody that plays 1 or 2 sports. So it's both circles, which is T or H. Add up those numbers, so 15 plus 27 plus 26, and you get 68. And that is the end of Venn diagrams.